Hello there and welcome to Lower 6 Maths. This is the Applied Practice Paper G. Here we're on question 6, a tricky SUVAC question. So a particle P passes through point A with velocity 2.8 meters per second and constant acceleration 0.12. Q does the same 3 seconds later with a velocity of 2.4 and a constant acceleration 0.2 meters per second squared. Write down an expression for the displacement of P and Q from A in terms of T, where T is the time after P passed through A. So it looks like here what we're going to need is a P SUVAT equation and a Q SUVAT equation, where we're going to have to work out S, and we know U and A in both of the situations here. So what we need is to set up a little SUVAT for both Q and P. So now going back through the sentences and picking out the important information. First of all, P has an initial velocity of 2.8 and an acceleration of 0.12. Q starts 3 seconds later. So if T is the amount of time after P has passed through A, then for Q, that's going to be T minus 3. It's got less time that it's travelling for. It starts at a speed of 2.4 and initial acceleration of 0.2 meters per second squared. Now what it's looking for us to do is to get a SUVAT equation. In this case it's going to be S equals ut plus half at squared for both P and Q. So for P, and it's in terms of T, so it can include T just like it is here in our answer. So for P it's going to be S equals 2.8 times by T, add half of the acceleration, so 0.06 times by T squared. And the same for Q, but remember in Q it's not just T, it's T minus 3. So S in this case is going to equal 2.4, lots of T minus 3, add half the acceleration, 0.1 T minus 3 squared. Okay, so that's the answer to part A. Part B is show that when the two particles meet, or in other words, the displacement is equal, we get this quadratic equation here. So S's are equal, so therefore P, 2.8 times T, add 0.06 T squared, is going to equal the displacement for Q. So that's going to be 2.4 T, and what I think I'll do is I'll expand the brackets at the same time here. So expanding the brackets on this Q part here, we get 2.4 T minus 7.2 as a number, add, and now expanding this, we're going to get 0.1 T squared, take away, and then it's going to be 6 times T times 0.1, so 0.6 T, and then it's going to be a double negative, so it's a positive 9 times 0.1, so that's 0.9. Tidying up what we have here, I think we'll take everything onto the right, so let's sort out the T squareds first. So 0.04 T squared. Now we'll sort out the T terms. So in this case here we're going to get 1.8 T, but then we're going to take away 2.8 T, so that's take away 1 T. And sorting out the numbers now, it's just minus 0.72, add 0.9, so that will give us minus 6.3. Okay, let's times through by, I think to get rid of this 0.04, we'll times through by 100. We might be able to do some cancelling out afterwards. 0 equals 4t squared minus 100t minus 630. And yeah, good, we're looking for this. So divide through by 2 now. I'm going to get 2t squared minus 50t minus 315. Perfect, that's how we've shown it. Part C now, find the distance from A when the two particles meet. Okay, so now what we're effectively wanting to do here is solve this quadratic equation. That will give us the time, and then we'll plug in one of those t values to give us the distance. So pull out that mode in your calculator where you can solve polynomials. You go to Menu, option number A, so scroll down, hit Polynomials, hit degree 2, and you're here. So type in that quadratic, and you get two answers. You're going to get t equals 30.2, and your second answer is going to be t equals minus 5 something, so you're just going to ignore that one. If it was a positive value, then you'd have to go with the smallest one, so when they initially meet. In this case they won't, because one's going to accelerate past the other one, so it's going to be t equals 30.2, and then go back to one of your formulas that you had before and plug in the value for t to work out your distance, and you're going to get s equals 2.8 times our 30.2, add 0.06 lots of 30.2 squared to find the distance now. So you're looking for distance here, so plug that into your formula and you get 139.2, so we'll say 139 meters to three significant figures there. Alright, okay, so that's 12 marks for that question. That's a bit tricky.